In this video, I'm going to show you how you can make a very basic procedural animation setup quite quickly for any character. So we're going to be using this character mesh, and I'm going to show you how you can download this for free as well, so you can follow along exactly as I am. So this is a very simple system where the legs will animate and it will respond to the direction that the character is moving in. And we're not using too many advanced features or anything too complex, but it should give you a good basis for understanding how you can start making procedural animations of your own. I'm starting off with a third-person template project. I'm going to make a new level. And we're going to go to Fab. So if you don't know how to get to that, do quickly add button there. Fab, that takes you to this. I'm going to search for robot. I think I'll choose this one. I've taken a look at this before, it looks good. So good job by whoever made it. I hope you enjoyed that shout out. Oh, done for easy. So then you click add project, select the version. It says it's not compatible, so you just choose the closest version, add project. And then you do a little time warp. And then it should take you to the character in the project. So if we go to mesh, you'll see SK Robot Scout. This is the skeletal mesh. We can just open that up, check things out. All good? Yep, perfect. Okay. So right click on him in the content browser, go to create, control rig, open that. So the first thing I'm going to do is just get his legs to move. And to do that, I'm going to use the basic arcade node. You could use the full body arcade, but especially with biped characters and trying to get some specific movements, I prefer using basic arcade. It takes a little bit longer to set up, but it's worth it, I think. So I'll search for basic arcade, we'll just do one leg at a time. Effector item, that's the bone that you're actually moving, so that's going to be the foot bone. So I'll start with foot R. Then item B is the parent of that bone, so that's going to be calf R. Item A is the parent of that bone, so that's thigh R. And if you make a variable, which is the rig element key, you can just put the foot R and make maybe a list if you want to loop through it or something. And to get the item B and item A, you can just drag out and do get parent and then get parent of that to plug it in dynamically. But for now, we're just putting them in directly. So the effector is where it's going to move to, and you can see it's just gone to some default spot. So what I'll do is I'll do get transform. And the transform is going to be the foot R. So that's where the foot is anyway when it comes in. So when it just runs into forward solve, it's taking that position. We'll plug that into the effector. I'll just connect that back. And now you can see that the foot is going to where it started, but you can see the leg's not happy. So what we're going to do is we'll open up the skeletal mesh. And if you go to calf R, click on that, press W to get to the movement tool thing, axis, whatever, widget, yeah. So what we're looking for is the primary and secondary axis. So if we set the primary and secondary axis in here, it'll know which way the leg should be facing. So to figure out the primary and secondary axis, the primary one is the one that's pointing down the leg. So it's down the bone that you're dealing with. So in this case, you can see the red arrow is pointing down the leg. If you look down this bottom left corner, you'll see red is the x-axis and it's going down in that direction. So it's following the x-axis. So primary axis is 1, 0, 0, as it was by default. So it's 1 on the x-axis and then 0, 0, 0. Secondary axis. Now the secondary axis is the direction that the knee should be pointing, or the middle joint should be pointing. So that's pointing forwards, his knee's pointing forwards, and you'll see that the green axis is pointing backwards, so that's the y-axis. So we know it's on the y-axis, but it's going the opposite way, so it's negative y. So the secondary axis is negative y. And now you'll see that his leg's pointing the other way. And what we need to do now is set the pole vector. So the pole vector is where the middle joint will try to point to, or the direction it's going to point to. So currently we've got it set to direction, which is fine. So all I'm going to do is basically tell it just to go infinitely or a long distance this way. So the knee is just pointing some direction that way. So within control rig, Y is forward for this character at least. You can see the axes again, bottom left. So Y is forwards. So all I'm going to do is put a high value in for Y. So it's 0 and then 100,000. And I can see that his knee's pointing forwards. And if we were to move this around, or this effector, his foot would come with it. And just to show you that, just in case you don't believe me for some reason, I'm just going to go to foot R, so you don't need to follow along with this. Right click on foot R, new element, new control, get the control. So we drag it in, do get control, and plug that transform in. Now if I move this around, you'll see his legs moving. So the approach we're going to take is basically we're going to make the feet, both of the feet, move straight forward and straight back. So they're just going to do this. And then what we'll do is we'll limit the distance that the target point can be from the thigh. So rather than it just going like this, we'll be limiting the distance where when it's lifting up or when it's sort of coming forwards, it will be limited in distance. So the limit will be reduced and then increase back to full. So it'll go like this. And then the other foot is going to be doing the same, but with offset timing. So anyway, where were we? Get rid of that control, we don't need that. We can just plug that back in. We're going to generate what will control the forward and back motion of the foot. And to do that, we're going to create a very simple cycle. So I'm going to use accumulated time, which just increases at 1 per second if the speed is set to 1. And we're going to use that to drive a curve, which is going to go forward and back. So if we search for curve, you can do evaluate curve. We could plug this evaluate curve in directly. What I'm going to do is a modulo, so search for the percent sign, modulo. This just strips out all of whatever this number is. So this will strip out all the ones and just leave us with what's remaining. So rather than this number going 1, 2, 3, 4, 5, every time it gets to 1, it will wrap back that round to 0. So we'll only get numbers like 0.1, 0.2, and so on, up to 1, and then it'll be looped back because we're stripping out all the ones. So we plug that result into the value. So the value that's coming into this is going to be a value between 0 and 1. So that's 0 to 1 on the x-axis. The y-axis, so the up and down, is what value it's going to output. And this is between 0 and 1 on this scale. You can zoom out, you can go beyond that scale, but I like to do everything 0 to 1, and then you just remap it after. So source minimum, I'm going to keep at 0 and 1, because that's our time range. This number can only ever be in that range. Maximum, we'll get to that, but I'll just put 0 and 50 for now. So if I just take this result and this transform that we've got from the current foot position, drop that down, drop down the effector, plug the rotation in directly. Translation, we're going to add a value to it. So just do add, plug that into the translation, and just in case, we'll plug scale into scale as well. So everything's just going across as it normally was. So nothing's changed here, and I'll delete that control because I'm not actually using it. So what we're going to do now is we're going to add a value to it based on this curve. So if we drop down B, we only want to move it forward and back for now at least. So that's the y-axis. So we're just going to plug the result into y. Now you can see that the leg is just moving forwards, and that's basically following this. So the number increases from 0 to 1, and it outputs this value, so however high it is on the curve. We don't want it to just keep moving forward and then snapping back. So what we're going to do is we're going to add a key. So you just right click anywhere on this and do add key. I'll select it, and at time 0.5, we'll say the value should be 0. So now you can see it's just paused for a while it's 0, and then it moves. I'll select this first key, keep it the time at 0, set the value to 1. So now his leg moves back and then stops and then goes back forwards. We don't want it to be going back forwards, so what I'll do is I'll set the target minimum to -50. So now it's moving a range of 100. So it's going from here, where it's plus 50, because that's the maximum output, to -50. And then we're adding that on to the translation. So far so good, but we also need to do the same for the other leg. So we duplicate all this, and you can do this in a loop, as I mentioned, but then you have to manually set the primary and secondary axis, so it just gets a little bit more difficult. So I'll just swap this one out for the foot L, and this should be foot L. Oops, misclicked there. Foot L, calf L. It's a lot easier if your hands work. Thigh L. Now, the primary and secondary axis of this are not the same. Usually they're inverted, so you can go and check at the skeletal mesh, but what I'm just going to do is make sure. Right, so -1, and that should be 1. and that seems to be right. Okay, so now we need to plug a value in for this add. So once again, we'll plug this value from our evaluate curve into Y. Now both the feet are moving in sync. We don't want that. So what we're going to do, let's just duplicate our evaluate curve. And this one is going to be controlling Y. We'll still use the same accumulated time, but we'll offset it and then plug it in. So we'll use another one of these nodes, so the modulo node. That goes into the evaluate curve. We will plug the time in, so it's going to be the time. So now everything's back the way it was, except we've got 2 copies of these nodes. But with this one, what we're going to do is we're going to drag out and do add, and we'll add 0.5. So what that does is, whenever this number's at 0, this one will be at 0, evaluates yada yada yada. This one will be, starts at 0, but then it gets added 0.5 to it, so then it's halfway through the curve, whilst this one's just starting. So this one's always offset from that one, so that's why the legs are moving out of sync. So now you'll notice that his legs are kind of swinging in an arcing motion. They're not trying to, it's just because with the base KK, they can't actually reach the target points. So I'm just going to move the pelvis down. So I'll do get transform. Fucking hell. Get transform of the pelvis. And we'll do a set transform of the pelvis. So drop down item, search for pelvis. Control click on that to move the execution path, so it's just connected up like that into the basic RK nodes. This transform goes into value. Can drop down both of those. Rotation, rotation, scale, scale, but the translation, we're going to add a value to that. And I always use add, you can use subtract because we are actually subtracting, but I just find it easy doing adds. So we'll do -30 on the z-axis. So you can see that his body's moved down. Now, what's happened here is he's moved the body down, but his feet have moved down as well. And the reason for that is because here we're doing get transform of the foot, and it's just the current situation of the foot, including any modifications that came earlier. So if I just cut out the rest of that, you'll see that it's moved all the body down. So all it's doing is offsetting the feet from this position. Instead, what we want to do is move the body, but have the target feet positions stay the same. So there's a few ways around that. What we could do is we could be promoting these to variables. So we calculate it first, where it should be, and then we move the pelvis down. Or we could add this value back on. So we've subtracted 30 from this to move the whole thing down. If we just added 30 on to this, which is probably the easiest way to do it, we'll always have the Z value back to normal. I'll just plug in the basic RK so you can see that. So you can see his feet are now on the floor. Now, I think a better way to do this would be to, as I say, save these to variables and then do the basic RK node after making that change, because we don't really want to be typing in these numbers and making sure they're the same. You could use a variable for those as well. So this would be subtract, let's say pelvis offset. This would be add pelvis offset, and the same there. But whatever, we're trying to do this quickly. So firstly, I'm going to just change the height slightly. So we'll go with -20. So that means this Z value needs to be 20 and this one 20. And maybe we can go even higher than that. Let's try offset of 10. Okay, so now what I'm going to do is make it so the feet aren't traveling as far. So the target minimum and the target maximum controls how far it's going on this y-axis. I'll change that to -30 to 30, so a total sort of stride distance of 60. And I need to do that for this leg as well. Okay, so we've got both of the legs moving. Now we want to make it so that the leg lifts up whilst it's transitioning forward as if it's lifted off the floor. Now, the way I'm going to do that, you could just make a curve which controls the Z value, which just increases the Z value and it lifts up. What I found a better way, or found to be a better way, is to clamp the distance the foot can be away from the thigh. And by controlling that, we force it closer or further away. And I just found that has a few advantages. And so that's what I'm going to show for now. So what we want to do, where we've got this get transform, we've modified it so to move it forward and back. This value, we want to clamp that relative to the thigh. So to do that, we're going to search for clamp spatially. we plug in this value, and the result goes into the translation. So it just carries on as it was, but it's going through this clamp spatially. Now the axis, that's irrelevant because we're going to use sphere as the type. I'll draw debug so you can see what's going on. So it's clamping it within this sphere. And currently that's not a problem because it's got all the space it needs. But what we're going to do is change the space to the phi. So that means that it clamps it relative to the phi. So it's going to be a sphere around the phi bone. So we do get transform, phi r. We could, let's just plug the transform in directly. So we've got the transform. So you can see that this sphere is centered around the phi now. The rotation doesn't matter because it's a sphere. So if I change the minimum, nothing will happen. If I change the maximum, what I meant to say, to 30, you can see that it's limiting the leg to only go that far away from the phi. So by changing this value dynamically, what we can do is make it limit how far away the foot will be. So now we just need to figure out the limit. So I'm just going to move this over because this is dealing with this leg. So I'll take this evaluate curve. So we've got a copy of that. I'll plug in the same value. So it's important that it's coming from the same thing. So the timing matches. So these two curves are in sync. Now what I want to do is I want to output a number which is going to limit the distance over time. So when the foot's moving backwards, we don't want any limit at all, or we want the minimum, let's say the maximum, the minimum limit, the maximum clamp radius. So we can take the value that's at 0, so 0 seconds, select that, set the value to 0. And then when it starts lifting, it's going to have more of a clamp to bring it close to the body, and then it's going to reduce back to 0. So this final value at time 1 is also 0. But then somewhere in between it needs to raise up. So we'll right click, add key, and you don't have to be precise with the time on this, but I'm just going to do it more towards the left than the right, and just set that to a value of 1. So now the clamp is at its smallest, let's say, at this time frame at 0.66 seconds. Now, the way we're going to do this, we need this to be a value that's going to work with this maximum. So let's just find a good value which will allow the foot to actually be on the floor. So 100 does, 80 is fine, 70 you can start to see the foot arcing. So what I'm going to do is change that to, let's try 75, 80, okay 80 works, so we'll use 80. So 80 should be, when this value is at 0, or the curve is at 0, we want this value to be 80. So what we'll do is we'll do target minimum set to 80. Target maximum, let's say, is 30. So it scales this value or changes this value between 80 and 30 related to this curve. So if we plug this result in, that will output the number 80 or 30 and the values in between. And if we plug that into the maximum, what you'll see is it very quickly snaps his leg quite high during that transition. So that's obviously too exaggerated. So if we just change this value to 60, you'll see that it lifts slightly. It's quite jerky and jumpy, and this is a robot character, so you know you can get away with some of that, but it looks shit, so we're not going to leave it like that. So what you can do is with this curve, you can select the points, right click, switch it to auto, and then you've got these control points, so you can change how the curve looks. So this one and this one, I'm going to switch to auto. So now you can see that it's got a more gradual ramp up. And I'll just move it around until it starts looking a little bit better. So you can make him stamp by having it that way. You can make him lift it early, but then gradually come to the floor. And I think the value is too extreme, so we'll just go to 70. Maybe not extreme enough there, 65. I'll put this somewhere more centered. And I'll keep that flat, so the curve starts flat, so it's more gradual. And we can play around with that, but what I'm going to do is just copy that and do the same for this leg. So we just paste that over here for this leg, get our clamp spatially node, plug in the value, that goes into translation. The space, we need to set that, so get transform, just using one of these nodes, except this time it's phi L. Pop that into the space. And now this evaluate curve, even though it's matching this one, the value we plug into it is going to come from this. So where we've done this, and then we offset it by 0.5, and then do the modulo. I'm going to plug that in as the value, and then we plug that into the maximum. So you can see that both legs are lifting, and I'll just turn off the debugs on the clamp spatially node so you can see that a little bit better. So you can see that both the legs are lifting. And I think what I'll do is I'll make it come down a little bit slower, so I'll make it just come to quite a fast stop at the end. And I'll do the same on this one. I guess I should copy and paste this so they're identical, but who's got the time for that? So we've got both of the legs or both of the feet lifting, and we've got values that can control that. And obviously you can use variables for these. So to do that, you can just drag out from that and do promote to variable, get some error, compile, the error goes away. Go to my blueprint tab here where you can see the variables. You can rename that. So you can say foot, lift, whatever. Compile when you change the variable name. So this is 65, but we could just play around with that. So if you want the leg to lift higher and so on, just change the number, put it back to 65. Make sure the other one's actually using the variable as well if you're going to use variables. So you can quite easily just play around with that and try and figure out something that looks good. So we've got the circle that's controlling the feet, and I'll just show you what that looks like when we're in game. So like I say, I just started with the third person template, so I'll just open the third person character, go into the viewport, select the mesh, and we need to search for our robot G. What's he called? Robot Scout there. Okay, so we don't want to use that animation blueprint. We actually need to create one. So we go to the mesh folder, right click, create anim blueprint. Now it's just in his default pose, and we will work on that. But what we need to do is right click and do control rig, plug in the control rig, select the control rig node, and we've got control rig class on the side. So we want to select the one that we've just created, which is SK Robot Scout Control Rig. When you compile, you'll see that his feet are moving. And so if we select our animation blueprint in our character class, we are using this one. Strange name, but okay. So now you can see that his legs are moving. If I just play in the viewport, he's skating around. So if you don't want him to be ice skating, and I'll show you how you can change that. So first I'll make him move at a more reasonable speed, because he's not running, so he should be moving a little bit slower. So max walk speed, I'm going to set to 150. So that was a pretty good guess for how fast he should be moving, or how fast his legs are moving. You can see that the feet are almost looking like they're locked to the floor. They're not quite. You can still see that there's some foot sliding, but all we need to do is, if we load the speed of the character, then it would actually match the animation. But we're not going to do that just yet. What we can do is tweak the accumulated time based on the speed of the character. So the faster the character moves, the faster this increases. So if I just change this speed to 2, you'll see that he's moving faster with his legs. If I go to 0.5, you'll see that he's making very small or very slow motions with his feet. He's still traveling the same distance, but he's taking longer. So at a speed of 1, his feet are traveling from as far forward as it can be to as far back as it can be. One foot's doing that, and then the other foot's doing that. So the total distance that he's going to cover within one loop of this, so in one cycle, where it's going from 0 to 1, this foot is going from plus 30 to minus 30. And then still, whilst that cycle continues, this foot is going from plus 30 to, or minus 30 to plus 30 to minus 30. I was right the first time. So in total, he's done 60 with this leg here and 60 with this leg, all within one cycle. So that means that he's moving at 60 times 2, so it's 120. So within one cycle, he's covered 120 units of ground. So if we changed the character movement speed to the walk speed to 120, what you should see is that his feet are aligned to the floor, and we do. So what we've done is we've cheated it a little bit because we've changed the max walk speed to match the animation. Really what you want to do is you want the gameplay to be driving what values you're actually using for the walk speed, and then the animation should match to suit that. So we've done the opposite, but that gives us some useful information. So I'm just going to add a comment under this saying 120 units per second for the character's move speed. That means the speed value for the accumulated time should be 1. And also we could say, whoops, not delete the comment. We could also say that if the character was moving at 240 units per second, the value would be 2. And if it was moving at 60, the value would be 0.5. And feel free to test those if you don't believe me. So from this, we can turn that into essentially a formula. So based on the speed of the character, we can just scale this speed value so that it always matches however fast the character's moving. But first to do that, we need the actual speed of the character. So if you go to your animation blueprint, what you're going to need to do is go to the event graph, try get pawn owner, and do get velocity. Drag out from the velocity and promote it to a variable, and that means that the anim graph can access it. I'll just call this velocity very creatively. Go to the anim graph. What we want to do is plug velocity into control rig, but we've nowhere to plug it yet. What we need to do is go to the control rig node or the control rig class, add a new variable. I'm going to call this input velocity. I've got the mic in front of the keyboard, so I am having a lot of struggles typing at the moment. Switch that to a vector. And if we click on that and we tick instance editable, then compile. If we go back to our animation blueprint, you still don't see it there, but if you go to this right panel, you'll see input, the input section, tick use pin for input velocity. And if anyone from Epic's watching, I have no idea what this output is for. Outputs would be very useful in control rig, but this seems to do absolutely nothing, and I think it's just confusing, so you should remove that. Anyway, so we now have this pin input for input velocity. Plug the velocity into the input velocity, and now control rig has access to that velocity. Within control rig, it's going to be a value of 0 or whatever you've set the default to. But when it's in the actual game, the animation blueprint is going to be passing that through. So let's take the velocity and we'll get the length. So the length of the velocity is the size of that vector, so that equals the speed. So if the character is moving at 120 units per second, which it currently is in our blueprint, this value will be 120. And what you could do is you could strip out the Z. So let's say the character is moving up a ramp or jumping or something, you've got Z velocity and you only want the 2D length, you can just do that. There might be a length 2D. There is not. There should be. So this value is the 120 or the units per second. So if we just plug this in as it is now, this will make the character go very fast. So it looks like he's going very slow at the moment, but when we see it in the game, as soon as we move, so we're passing the velocity in, but it's going very, very quickly. What we want to do is just divide that. And we know that this value should be 1, given our current move speed. But we know that the input velocity is going to be 120 because of his walk speed. So if we just divide this by 120, plug it in, you'll see that when he's moving, his feet are perfectly in sync with the floor. But because we've made that a formula, or we've figured it out formulaically, what we can do now is just change the walk speed. So let's change the walk speed to 60. And now his legs are still staying in sync. And they're not quite meeting the floor. I think that's just because the mesh isn't quite aligned. So turn off snapping. I like how they've swapped around the positions of all this in 5.6 just to make things more difficult. So you can see his legs are locked to the floor even though we've changed the move speed. And I'll just change the speed back up a bit. So I'll go to 135, make sure that's working. And now we've got it that his legs are in sync with the floor at whatever move speed. And because this is quite a simple tutorial, I'm trying to do this quickly. I'm not locking his feet in place, so if he's rotating, you can see that his feet aren't perfectly matching the ground. But if the character's moving fast, you're not going to notice this. And what you can do is you can lock these values, so wherever the feet get moved to, you could be saving this in Worldspace, so you convert it to a Worldspace coordinate. And then you don't update it if the foot's on the ground, you only update it when it's moving, and maybe lurk between the two and so on. I cover a lot of this in my courses and other videos on this channel. But for now, we're just going to try and keep things simple. This is more about the actual motion of the character. So before we go too deep into changing the motion of the character, let's get him out of this A pose. So to do that, what I'm going to do is create a new level sequence. So you drop down here, add level sequence. Click that to save. If we go to our content browser, you can open up the skeletal mesh, and in the asset details section, if you search a rig, default animating rig. So let's click on that. So what we could do is we could go through the modular control rig to set up a control rig for the character. I think what I'll do is I'll just wing it, and we'll try with the CR mannequin body. And now if we drag him into sequencer, because sequencer should have opened when you made a new level sequence, you can see that, okay, his controls are there, they're not quite aligned to the body. You can, yeah, let's just deal with it. We're only making some small adjustments. So what I'm doing is I'm just going to move his feet close together. So I'm just going to select the IK for this foot, move it over there, press S to add a keyframe. And also you can click this, so it will automatically add a key when you change something that already has a key in that channel. And I have a course on animating in sequencer, so I'll go through all that. I'll just move the IK targets slightly. We might use those. Currently we're not doing, because these are essentially pole vectors, and we're just setting our own value. But what you can do, there's a node that's called compute pole vector, where it will figure out where the pole vector is on the character, so where he is given the input pose. And then you can just modify that, so you could rotate that and so on. I'm not going to do that at the moment. So let's just try and move his arms into a more robot-y, relaxed pose. This is quite difficult because the controls aren't in the right place, but I just want his arms sort of like facing straight forwards, like robots tend to do. The perfect pose. Okay, done. Right, let's just make sure we key all of these. So if you just select the CR mannequin body, press enter, that'll add a key to all of the things. Save. And now if we right click on robot scout, we do bake animation sequence, and I will call this super realistic high quality pose. Export to animation sequence, and now we've got an animation sequence. So now we can close sequencer, go to our animation blueprint, and you should see it down here now. So we've got that pose, drag it in. Well, it's an animation, not pose, but yeah. And now you can see that the control rig's still being applied. It's just that now it's being applied given that the default pose is no longer this. It's, if we go to preview, what we can do is use a specific animation, and we'll set it in here. Why is that not working? Okay, so if this was working, which it seems not to be, you'd now be seeing him in the actual pose. Okay, for some reason that's not working. That's never not worked for me before, but you should be seeing him in the pose. I'll just close control rig, which tends to fix most things. Reopen, preview settings, specific animation. There we go. Just control rig things. So now he's in that pose. So when you're making changes, it will be easier. And also you can set some default input velocity. So this isn't using the animation blueprint. You can set it to the running instance if the level's playing, but I'm just going to set a default input velocity just so we can preview what things are looking like within Control Rig. So we've got the details, we've got input velocity selected. Let's just give him a Y speed of 135. Compile. Connect things up. So that should match what you'll see when we actually play. And it does. So now to add extra motion. So I recently made a video on Motion Rig, which was an epic mega grant, which I didn't receive, by the way. So give me a like in commiseration for that. Where I talked about controlling different parts of the body based on one thing moving. So for example, the feet are moving, so that means that the pelvis should move, and then the upper body moves, and so on. And also you can control things through cycles. So this is a cycle that we're generating. And using this cycle, what we can do is we can control different parts of the body. So what I'll do is, since we've got this pelvis offset, I'm going to essentially modulate the pelvis offset so it just goes up and down as he's walking. And I'll just use a curve for that probably. But we need to remember that this value needs to be subtracting or adding it back on. So whatever we take away from this value needs to do the opposite, as well as this for this foot, because these were the offsets for the feet, just so that when we move the pelvis down, the feet would actually be moved back up into place. So what we can do is we can use another curve. So right click, evaluate curve. We'll plug in our accumulated time. And this is without any offset. So this is not the one where we're adding something to it. This is just the normal one. And we'll plug this value into Z. And let's say the target minimum is going to be -10. Target maximum is 0. So that's how far he's going to move, if you saw that. And because we don't have a modular node, it's just going from 0 to 1, it's carrying on and nothing's changing. So we want a modular for this as well. So now it should just keep looping where it's going up and down. Now, if we modify this curve, so I'll set the endpoint to 0, the start and end point want to be the same, so it's a seamless loop. So this is looping from 0 to 1, and currently the output is 0, so it's not offsetting the Z height at all. If we add a new key in the middle and raise this up, you'll see that he lifts up during the middle part. And I'll just make this quite exaggerated. Well, what I'll do is I'll just drag that up. So now you can see that his feet are going nowhere near the floor. And if I do the opposite and it goes below, his feet are going below the floor. So what we want to do is just take that, multiply it by -1. And we're going to plug that into these Z values where we're offsetting what the feet are doing, just so that the feet stay exactly as they were. So you can see this foot that I've done it for is staying in place whilst the other foot is not. So we connect that to the other foot as well. And this is all getting quite messy. You should really be using variables, and you can collapse things to functions. So you can select things, right click, collapse to function, and so on. And then you'll have inputs and you won't have all these lines everywhere. But for the sake of time, I'm just doing it like that. So now we have a curve, and you can zoom in with the mouse wheel and you can zoom in on the graph with the mouse wheel. So you want to get the graph as big as you can, and then you can just zoom this to how you need it to be. So at 0, when this value is 0, that means that the right foot is as far forward as it can be from this curve. And the right foot is going from the front to the back. So that means that the part of the cycle that he's in is with his foot at the far front and his other foot's at the back. Now, when walking, that would be the lowest point. So here, we've got these as the lowest points. Then, when his foot is centered, so that will be halfway through this portion. So this portion is when his foot's moving from far forward to back. Halfway through that is when he's going to be at his highest. Then he goes back to low, and then the same for the other foot. So when it's doing the other thing and the other curve over here, it's doing this, but relative to this time frame, it's over here. That's when he's going higher and higher until his feet are like directly underneath him, and then he goes lower and lower towards the end. So what we need is we're going to need a few more points. So we'll just add a few keys. So we've got 1, 2, 3, 4, 5. So the middle one is staying at 0, so just set that to 0. The end and the start one are at 0. These two I'm going to raise to, let's just try raising them both to around 1. So I'll set these to 1. And now you can see that he's raising up. Now I'll just select all of these points, right click, auto. Now it's smoother. Now he's looking very bouncy. I'll reduce this value so it's not going to -10. I'll go to -8, and I'll reduce the target maximum to -4. So you can see that it's just making some small steps now. And what we can do, which again, that motion rig thing, I do a lot of this, you can offset the timing. So by manipulating the timing, you'll get a different look. So what we could be doing is we could be selecting these nodes and shifting them left and right, but then you'd have to have more copies of it on either side if you're shifting it. So an easier way to do that is you can just offset it before this modulo. So if I just add a value, so to put him exactly out of sync, where he's going to be higher when his feet are far apart, I can do 0.5 and offset the cycle by half. That gets banged into there. And now his cycle is offset with his pelvis. If I change it to 0.1, you'll see that it's changed again. And it might not be too clear, but it makes a very big difference, these exact timings. So what I would do if this was for an actual project, I'd recommend just playing around with these values. You can also do negative values as well, to where you think it looks the most natural. And you could figure it out. You could look at examples of walk cycles and so on. For a robot, it's not, it might not be the easiest to find good reference footage that looks how you want it to look. So just try out different values and see what looks good. So I think that looks somewhat natural as a starting point, at least. So we've got him moving up and down. And what we can also do is we could apply some of that motion to some other part of his body. So let's say we wanted his head, just as an example, to sort of bob up and down with the motion of his pelvis. We can do set transform. And you probably get the idea of this by now, but I'll just control drag that to there. Item, choose his head. So we'll get the transform of his head, because he's lost it at the moment. It's in the floor. Now, if we just plug this in directly, his head's back to normal. Plug the rotation in, scale in, and translation in. What I'm actually going to do is manipulate the rotation of his head. So this is a quaternion, and that means it's confusing mathematical magic. So we don't want to deal with that. What we're going to do is drag out to the left from rotation and do from Euler. So from an Euler angle, which is just XYZ, and then this one is going to be make two Euler. So if we just plug these in, the rotation will just stay as it was. But what we want to do is, I'll just compile to get rid of that warning. What we want to do is change one of these in sync with this, and maybe we'll use a different curve and offset the time slightly. So firstly, let's figure out which axis we want to rotate it on. So I want him to be bobbing his head up and down. So we can go and take a look at the skeleton, search for head. Oh, there's a lot of birds outside. So we want to, it looks like we want to rotate on the z-axis like that. So z-axis, let's just add a number to it. I'll just add 45, and it should be looking down by 45 degrees. Okay, so if we modulate this value by some curve, then his head will be bobbing up and down. So I'm going to take the exact same curve and the modular node. We'll plug that in there. And the values we're going to use, I'll use, let's say, +10 -20. So that's the minimum and maximum. And the value we're going to plug into this is going to be our accumulated time. So you can see that he's nodding. He agrees that this is a very good way of doing things. So like we did with this, where we offset the timing, we can do that here. So we plug the accumulated time into the add node, plug that into the modulo, and let's say we just offset it by a negative, or let's just do positive 0.5. He's bobbing his head a lot. Try some different numbers out. I'm keeping it exaggerated, so it's obviously too much movement there. But before we turn it down, I'm just trying to figure out what timing would work. It's easy to see when the movement's more exaggerated. So I think something around 0.7 seems to look somewhat like it's responding to the motion of his pelvis, like it's bobbing up and down just after his pelvis does. So now let's just tweak these values. So let's say the maximum is 4, and it goes to -4. So you can see that he's just got some slight subtle movement of his head whilst he walks. And now let's do the same for another bone. So let's do it with his spine. And it might get less and less robotic the more you do this. But if you're doing this with a human character or something, obviously you don't want it to look robotic. So I'm just going to copy all of these nodes so we don't have to create it again. And you could definitely turn this into a function. So you just pass it the bone you want to change, the axis you want to change. You could even put this curve into a function and so on. But for now, I'll just copy those nodes, paste them here, connect the execution path. So that was to that, and that was to that. And now we want to swap this for spine. He probably can't move his top spine bone. Oh, he's only got 3 spine bones. So we'll just move spine 3. And set spine 3. So we need to plug in the time to this. So now his spine and his head are moving perfectly in sync and the same amount of rotation. So it looks kind of weird. Let's offset the timing of that. That looks even worse. Okay, this looks this doesn't look good at all. I'll just tweak some of the numbers. I'll just turn this down. I've basically just turned it off because it doesn't look good, but it was worth trying. There, so that doesn't look too bad. So I think that looks okay for the spine. And I might just quickly go through and do the same with the arms, just so the arms don't look like they're locked in place. So what I'll do is I'll just rotate the lower arm in sync with all this. And I might speed through this in the video because you should get the idea of what I'm doing. Just copying all the nodes, changing the bone that it's affecting, plugging something else in. So I'll see you on the other side. Okay, so I've done the same for the arms, and you could slow the video down if you want to see the exact values I used, but who cares? So his arms are rotating as his pelvis is. And remember that all of this is being controlled by this input velocity. So if the character was moving slower, it would essentially be, I'll just change the input velocity default. I'll just change this down to 60. So you can see that it's all moving in sync. So his pelvis is moving up and down slower, his legs are moving slower, his head is, chest, everything's being driven by the same value, so just this input velocity. You could also drive it by something else as well, so you could pass some other information in about the character and use that. So this is a simple procedural animation that we've created entirely just by putting some nodes, modifying the character and so on. But whilst we were in sequence and making the pause, we could have probably made this animation in a shorter time. We're not really taking any benefits of procedural animation by having done this so far. But one way that you will get some benefit is if the character wasn't moving straight forward and he was moving at a different angle, we can make it so that his feet are going in that direction, which is very useful for procedural animations. So currently what we're doing for the direction his foot moves is, and we've got all sorts of shit, so it's difficult to keep track of, but this is controlling the direction his foot's going to move, and this one here, I'm just going to swap the positions just so they match. So that's the up down, that's the forward back, this is the forward back. What we can do is we could also tweak the forward back curve, so the curve would be smoother. So we'd want this one to be linear because this is while the foot moves from far forward to far back, and that needs to be tracking the ground, so tracking the velocity exactly. But then we could make it from here to here, have a bit more of a curve to it, so then it doesn't jump forward quite as fast, and you would have to do that for the other one as well. So currently, I'll just show you on this one. This is just setting the Y offset of the foot. Instead, what we're going to do is we're going to use this number to drive a direction or a vector, which we then add to this in its entirety. So it won't just be the Y-axis, it'll be the X-axis as well. So we'll do another add node after this. You could do add pin, but I prefer to just do a second add node. What we're going to do is take the Y out of that. So I've just alt clicked on that to remove it. So we're just looking at this left leg for now. This value is going to be multiplied by, no it's not. This value is going to scale a vector. So we do a scale node and we're going to plug a vector in, and the vector we're going to use is going to be the input velocity. So we get the input velocity, and what we could do is we can do unit, which is normalizing the vector. So it could be called normalize, but it's not. It's getting a unit length version of the velocity, and then we scaled it by our number. So if we add this to the foot position, you'll see that everything's back to normal. Or is it? Not quite, but let me just do it for both legs. So we'll just take these 3 nodes, take the add node as well. And this is very messy, just ignore that. So this adds to that, and then it goes into the clamp spatially. Hopefully you're following along enough that all this chaos and lack of functions is not too distracting. So we're taking the input velocity, normalizing, then scaling it by this result, and then we're adding that on to the foot position and then before the clamp. So yeah, before the clamp there as well. And something's going slightly wrong there. The foot's going weird. Have I missed something? Oh, we've also got the Y plugged in, so we've got it. So we need to unhook that Y. Okay, so now both of the legs are moving exactly as they were. So everything seems to be back to normal. However, it's not. If we start making him move, he's doing a little dance for us instead. So that's an extra bonus. I could have made that separate tutorial, but look, he can even cross his legs. So the reason it's going weird is because it's using the velocity that we're passing in, but the velocity we're passing in is a Worldspace velocity. That's just from the animation blueprint. We're just getting the velocity of the character. So that's how they're moving around in the world. Whereas Control Rig deals with everything in Rigspace, and it also calls it global space. So within the reference frame relative to the character. So we're passing a Worldspace coordinate in and trying to treat it like it's a Rigspace one, and it isn't. So what we need to do is we need to modify our velocity, so our input velocity, and we need to make that relative to the Rigspace rather than relative to the world. So I'm going to add a new variable. That's going to be a vector. Rename this to rig velocity. Alright, so we'll call it Rigspace velocity. Drag this in. I'm just doing this at the start of forward solve. So we're setting Rigspace velocity. So we'll start off with just setting it to the input velocity. And now wherever we used velocity, so in those 2 places where we used velocity, let's just use Rigspace velocity. Now we need to turn this input velocity, which is in Worldspace, convert it to Rigspace. So let's say this value is 135 on the y-axis. The way I would think about it is the world origin, and then we go 135 in the y-axis. So that's down this axis. So that's like a position over here. So 130, 1350, somewhere around wherever that would be. So that's just a line. Whereas if the character's over here and we're passing in this position, relative to the character, that's not correct because it depends on the character's rotation. So you'll see that if I rotate the character in a certain direction, it actually aligns. So if I'm going that way, everything's aligned, just happens to work. But in other directions, it doesn't. So that's exact opposite. So his legs are going the opposite way. So what we want to do is we essentially want to say, where is this point relative to the world? And then use that, because relative to the world, okay, we know what it is relative to the world. Now let's apply that same value to our character and make it relative to our character. So the way I do that, and there might be an easy way to do this, but what I do is, firstly, we're going to do a make relative node. So search for make relative, and that makes one thing relative to another. So plug in the value like that. So this value here, the input velocity, is in Worldspace. So we can drag it from that and do from world. So from a Worldspace coordinate and convert it to a Rigspace coordinate. Plug that into global. And the thing we want to make it relative to is the world. This is already relative to the world. So we want to get the world space and then convert it from the world space coordinate 0, 0, 0 essentially back into Rigspace to use as a parent to make it relative to that. And I don't think I explained that very well, but it's only these nodes, so just remember this if it's easier. So what we're doing is plugging the from world, which has a value of 0, 0, 0, and then the input, which is 0, 1, 3, 5, 0, converting them both from Worldspace to Rigspace, making one relative to the other, and then we're just using that value. And now what you'll see is that he's moving in all directions. His legs are moving relative to the actual velocity of the character. Now, if I go left and right, he's actually turning, so I'm just going to turn that off. So in the character component, it's orient rotation to movement. So untick that on the character movement component. And now you can see that whichever direction I press, his legs are moving in that direction. What you could also do is take that Rigspace velocity to rotate his upper body or his head if you wanted to, for example. Or what I prefer to do is rotate his whole body, so his pelvis would rotate in this direction, but then rotate his upper body back by the same amount. So the character still faces the direction you're facing, but his lower body, like his pelvis, would be facing to the right and walking straight that way. That depends on what style of character you're going to do, and there's quite a lot of detail to that. I do cover that in one of my courses, and I've mentioned my courses a few times. And one thing that I've noticed is that his legs will just instantly snap to the direction that he's moving in. So if I change direction, his legs just instantly snap to the new direction, and you get some snappy movement. So because we're using this variable now, rather than the input directly, what we can do is we can take this and do a spring interp node. And a spring interp node crashes the editor. Okay, so I'm back after a restart, and that's a reminder to save often. So now I'll show you the other use for the spring interp node. So if we do a spring interp, what this does is it tries to reach the target. So whatever we plug into the target, it will interpolate towards that value based on the strength, the damping, and so on. So I'll just plug this in and then plug the result into that. So rather than it just setting this value directly, it has to pass through this spring interp node, which essentially slows it down because it's only trying to reach the target from whatever the last value was that passed through this node. So it's trying to ramp up to the speed or the new direction and then back down again and so on based on these strength values. So if I just set the strength to 1, what you should see now is that if we change direction quickly, his legs are smoother doing that. Although it adds some foot sliding because it's maybe too slow now. But you can see that when I quickly change direction, his legs aren't snapping around anymore. So what I'll do is I'll just increase that strength maybe to the default of 4. And now that looks a lot better. So there's not too much foot sliding between the transitions between directions. And there's not any snapping when we just press like A and D. Now, obviously to improve this, as I say, you can lock the feet to the floor so that when you're doing transitions like this, the foot that's grounded will stay locked and so on. And something else that you may want to do is shift the pelvis to the left and the right. So when he's got weight on one foot, you shift it over and so on, and you tilt the pelvis and things like that. But hopefully this is enough groundwork for you to just start experimenting with your own ideas and just get some animations going. You can also use traces, so that's important with procedural animation because you want these feet to actually look like they're reaching the floor. So if you had some object or landscape or something like that, to do that you just do a sphere trace by trace channel. This works the same as it would in Blueprint. Start point, end point, it does a trace, hit location, gives you the hit normal. You can use that to position the feet. So you can use the aim node, so use that to rotate the feet to make sure that they align with the floor. You have to mess around with the primary axis and the secondary axis to get that to work. There's also, if you don't want it, this will actually set and modify the bone transform. But if you just want to get the transform and do with what you want, so you can plug that into the basic arcade node, you can use the aim math node. set up the same. So you've got a primary, secondary axis, yada, yada, yada. You put the target would be the normal. So the normal from this hit will go into the target, as well as the target for the secondary axis. You need to set the axes. I'm not entirely sure how you work those out. Sometimes it seems a little bit, it doesn't quite make sense to me. I'm not sure if the nodes are wrong, or I'm just not understanding how the primary and secondary axis works in terms of aiming. But yeah, I've covered some of that before. You can just try things out with that. So yeah, hopefully that's a decent basis to start doing some procedural animations. Buy my courses. Thanks for watching.